All right, good day everyone, and welcome to the part 4 of this series um, on Printf. We are trying to learn how to implement our own Printf, partially at least. And we've tried to understand how Printf behaves, and which is very powerful, it's a prerequisite for you to be able to implement. You can't implement something no ideas. And so we've gotten this far, and today, in fact, the last time, yeah, I remember the last time that was in the patrol. Now I talked about the difference between percentage D and percentage I. That question I've been asked that question several times, and I keep wondering. So that day was an opportunity for me, to explain it practically. I mean, how do you want to explain that thing without practicing it, without showing practical codes? So that was an opportunity for me. And today, the first thing I'm going to do is to go in. Yeah, I'm going to make a copy of part 3 directory. I'm putting this directory here so that you can go back to them later, play with them. I want to copy this into part 4. That will be the one that we improve upon. Okay, we have part 4 now. You know how we roll. I'm using the left side for my editor and the right side for my terminal to run my code. So here we go. What is left for us to implement right now is percentage, like I've said. That's like me repeating myself. So I'm going to start by opening the file. By the way, just to show you again, these are the files that are here. We have an executable main.exe. That's because I'm using Windows. It would have been just main. We have the main.c file that we created to test our code, to see how it's working, to see how we can compare it to the standard library Printf that we are trying to emulate. And then we have put_s. In fact, in this main file, I want to stop using I want to entirely not use printf down here. I'm using puts. This is the standard library function here. I want to use our own entirely. And I'm using my printf, yes, and I'm using printf here again. That's because our printf is not capable of printing this yet, printing percentage. Handling we don't have this handler, this conversion handler yet, and so hopefully we'll have it by the end or before the end of this particular session, and then we'll take this guy off here so that we know that everything down here is our own, then everything up here is from the standard library. Yeah, so we can confidently compare ours and theirs to see how it's working. So let me start by implementing puts. I already have something that looks like puts, but the difference is that one does not print a new line. What was that? That was put s. So I'm going to copy that put s. And I don't have to add it. I can't make this one print a new line. It will spoil our percentage s conversion handler. So let me just make my puts. So put s. Let's see. I'll copy it to a file. Name my puts. Let's see. So I will go into that file. What I want to do here now is just add a new line after everything. Simple. Just add a new line after print. What am I doing? Why is it? Okay. Could that be? No. I'm in the wrong place. Should be here. So put a new line for me. By the way, my Putchar. I don't want to start a library here. So put this. Here we go. So this will like it. I like having a space from a free line before my return value. Rated card is 20 minutes. Okay, I'm making progress. I want to go into the main .c file and remove this guy here. I now have a guy that works like it. So let's use my own. My puts. Something is not right. Let me go back to that file. You need to have a different. I need to work on this line. So my puts. Yeah. So my puts takes a string and does this to it. Returns integer. This is cool. This is cool. So I'm going to copy this. So I'll have it in the header file. What's the header file again? I think header.h. Yeah, that's one of the prototypes. Okay, column making progress. Let me be sure that it's working. You know how we roll. So GCC everything here and give me outputs min. And of course, we should expect them.exe because I'm using Windows. Windows will always add exe to the secondary files. Expect you rename it, and if you rename it, it will be adding this asterisk here or star, making it look like it's a pointer. Okay, now let's run this file and see whether it's still working. Okay, so where's that put? My put did not work well. My put did not work well. Did it work well? Okay, it worked. It worked using printf. Using my printf, using printf, it worked. It worked. It worked. So we're having exactly the same result. The only thing now that you're going from the final library is this guy, what you're using to print out this guy. By the end of this part, we shouldn't be using it again. Let's make progress. I'm going into the file, my printf.c. And now we want to handle. We have handled between line 14. We said don't print percentage when you see it. Between line 15 and 19, we said is it between or within those lines? We said when you see C as a nesting after percentage, this is what we do. It means go for the next number on that list. You know, this is the logic function at work, right? Put for the next number on that list and get the content or get the particular character there, int that single character there, and return int, of course. You know, and then here within line is it 2021 to the 5, we say check if the character after percentage is s, then we use a function that prints strings, you know, that we look through to iterate through each element in that string and print them all out, you know, and that's what we did, and it worked for us. And then we checked for the next character after percentage being another percentage, another % sign, that it should, and we'll give it that it just print that percentage sign, just print it, you know, and that's how printf behaves. And then let's go ahead. The more efficient way of writing this code anyway, that will make this line shorter. But the writing is working, so let's just keep moving. Else, if I think I should just copy this. So Q yank and change this to D. Or yes, I think we need to put it to or let's do this again.
Topman, they're requesting that you should slow down a little bit. It seems you're going a bit fast.
Oh, I'm out to wow. I was even looking at
And also a bit louder, please.
okay.
Thank you.
Thank you. Whoa. Okay, but
Hey, that's the volume we want. That's the volume we want, sir.
Yeah, I'm actually trying to shout at the top of my voice now. Maybe you wouldn't feel so if you had taking a look at the other part, but no problem. We're making progress. So you're trying to check for who knows the shorter way to write this thing, to write this code I'm writing here. This particular line 31. If you know, teach me, or teach us. So I won't learn how to write all these petty things. Someone unmuted. Want to talk to us? Okay. I'm making progress. So if this or this, if any of these evaluate to be true, this is what I want you to do. And what do I want this guy to do? What do I want this guy to do? Now let's try this. Right? This is predict function now. Right? And right there on line 17, as you can see, that's a line that got what's it called? That got the character. Yeah, that got the character out and printed it. So it means that if we do this, it should be able to print the number. But then the problem now is I'm trying to recall something. I'm saying something. Okay. I was wondering why I did int alpha in line 22. I've seen it. By the way, don't in better we don't let this. I mean, those headers, those cancel of headers. Write extra, write error, write all. Those guys, they're not joking with you. don't declare a variable. And yeah, take it up. All your variables, get them up, and give a line between the declarations up there and the other part of your code. Okay. Now Putchar does not print decimal, but there's a way you can trick it to print numbers, right? There's a way you can trick it to print numbers. And let me do that. You know how we roll. Let me save this file. I need to go into this test file. This test is here. We gather. Should I create another one? Should I create another one? Let me see what I have there. Let's play with Putchar a bit. 4, 5, test 5. I think I should continue here since I numbered them. Alright, so let me move into the test file. I want to create a new file there inside the test file, inside the test directory rather. I'll call that one 5 tests. Let's see. I will save. Let's go and play with Putchar a bit. So I don't want to write plenty. So I'll just copy what I have in 4 test.c into 5 test.c, hoping that I'll only need to just edit a few lines and that'll be all. So yes, of course, at least I have the other file. I have yeah. So we did something like that last time, right? Wow. Okay, I've explained this part now. Cool. So let's make progress. Now this was a trick to print 9, and I told you how it achieved this. It achieved this, right? I think it achieved this. Let's go back. I will take this off this file. We rather use it for another test. So let it be empty like this first for now. Let me go back to 4 tests.c. Okay, that will do this, and I will do more just to explain what happened again, how this came to be. So kill yank again. Let me pick a number at random here. Let's say 15. Let me pick a number here, 3. and we'll find out what happened, right? Let me take off these values just for emphasis to emphasize what really happened here. Now, what will happen here is this: when you do this, that's why you can actually save this inside an integer variable. You can actually save character like this. Now, what happens here is you are asking Putchar. When you give Putchar a number, let me take it bit by bit. The Putchar we know prints only character. So this is not strange for Putchar. It's not strange to say Putchar print D for me. It's not strange. You know what will happen. You know you print D. If I say Putchar print 65 for me, as far as Putchar is concerned, it is not going. It is not even seeing it is not seeing this thing you're giving it. It's seeing the character that this value 65 represents. The character that has a decimal equivalent 65. That's what it's seeing. And in this case, it's uppercase A. So if I go back and compile that file for test.c, this is C. I'll save this. Okay, this is C for test.c and call it for test. What's up? No such file. What exactly is the problem? Why are you saying this first file entry?
The
Okay.
option flag for dash O for the output to the file.
Okay, I was actually giving you 2 files. Okay, thank you. Right. So Putchar prints A. You can see it down there. It printed A because 65 represents A. So at this point when we are giving Putchar the number 9, it was not seeing number 9, it was seeing what 9 represents on the ASCII value or the ASCII value of 9. Up to now, I don't know which one's really the correct pronunciation. ASCII, ASCII, whatever. You know what I mean.
Like ASCII.
ASCII. Okay, let's take ASCII. ASCII. So you see the ASCII value of 9. So when you say 0 and you put it as character, it concatenates these two. And for you to concatenate, it's just like in mathematics, you cannot. There is no way you can make this 2 plus d. The only way 2 plus d. What will 2 plus d do for you? 2 plus d. You can't. They can't be 1. They can never be 1. This way, you must have the d there again. So equal to 2d. You say 2 times d. 2 times d. You end up having something like d squared or something, So that's the way. You cannot turn this into be 1. You cannot turn this 9 and this character to be 1, except they are of the same type. So it converts this guy into the type that this guy is, and it concatenates them together. It adds them together, right? And the character 0 itself has decimal value of 8, and I showed you that. Yeah, let me get it again. Ta-da-da. Hey, don't delay me. Alright, here it is. I'm going to zoom in so just make sure that you see. Now this is it. You can see that here the first thing here is decimal, followed by binary, followed by octa, followed by hex, and the ASCII, the ASCII. Sorry. So we are working with decimal and ASCII right now. So you see that this 9 is not What does setting mean? I don't have this in my head. I know that BS is backspace. This one is bell. Okay, that's by the way. Inquiry. I don't know what setting means now, but that's what 9 represents. This is what Putchar would have gone for, and which may not be something that it may not be okay. Let's just leave that. This is what Putchar would have printed. But when you say plus the character 0, it goes to check the character 0. Where is the character 0? And this is the character 0. So the value of the decimal value of the character 0 is 48. See by the left. Remember, we're just dealing with, forget about this binary, this octa, and this hexadecimal. Forget about them. We're dealing with just this one by the right and this one by the left. The one by the left is the ASCII value. The one by the right is the decimal value. So it sees the decimal value of 48. I say, okay, 0 is, and 48 plus 9 will give you 57. That's how it's able to go and print the character. We trick it to go and print 9. So it goes here and it becomes 57, and then it puts what 57 is, which is this. That's how we get this result that we have here. Emacs, where are you? Okay, that's how we get this result 9. So when it does, okay, let me do it this way. This thing will turn to Putchar 9 plus 48, and then it will be equal to Putchar 57, which will be equal to 9. So something similar will happen here. It will do 15, and watch now. This thing works for only 0 to 9. It works for 0 to 9. This is like, let me just put a comment here. Making 0 to 9. Okay. So let's see what happens with 15. Let's see what happens to 15 now. So 15, you're supposed to have it do something like this. Putchar 15 plus 48. And that will be, somebody help me now. I'm waiting for the answer. 15 plus 48, LAX.
I think it's 63.
63. Was it that told me? If it's wrong, you don't told me. 63. Ah, that must be a Nigerian. Okay. 3 plus 48, please.
51.
Thank you. Since I've got 2 very active persons here, so okay, let's now try to predict what these guys will print. It's a good habit to try to imagine what your compiler would do first, the output of your program first before you start running it. You don't say, let me run it and see what will happen now. If you're able to predict the outcome before it happens, man, kudos. That's a good one for you. It's a good habit to develop. Okay, so let's try to predict what it will print. So this is 63. Let's go for the value of 63. 63 is down here. 63 is the decimal equivalent for the character question mark. So we are expecting that guy to print question mark. That's the story that it does not, when you go beyond 9, you can't get the number 9 again. So we are expecting question mark to be printed here. And so for 3, here is 3 plus 51, and 51, this is 51. 51 prints 3. So by doing 3 plus the character 0, we have just made Putchar to print 3 for us. 3. So it means that this program now, what we are expecting to print is, oh, this one is a comment. Come back, become a code. So what we are expecting from this program now is this. It should print 9 question mark, because we don't add any space on any new line, and 3 like this. And then Windows Windows uses to add a new line by default. That's what I've experienced here. I don't know whether it happens only on my computer system. Now I've saved it. So let's go and run. This is for test.c, right? Let's go and run it. Oh, it's print more than that. There's a line. The line up we print A. So uppercase A, 9, question mark and 3. So this is what I expect. Here we go. Compile again. Let me clear the screen and run the file for tests. Wow, interesting. So it gave us the output A9 question mark 3. Form that habit before you don't just rush into running the program. Look at it. What will you print? What will you print? Try to predict. If what you predicted was entirely different from what the outcome, ask yourself, how come I have not still understood how the compiler thinks? You work some more, do some more work. All right, now you understand that part. It means that we don't to be shaking and saying how are we going to print how are we going to print what's it called, numbers, integers in our function now. How are we going to print it in our function? You can see now that at least we can print 0 to 9. That if I go back to my printf, and say that okay, when this guy happen, print Putchar the member. Very interesting. Very interesting. Very interesting how to do here now. Go for the member of this guy, and that member will likely be an integer. Go for it, but don't just go for it. I want you to concatenate it with the character 0 and give me what is inside there. Okay, so I want to put these 4 things inside the bracket just to make sure that there's no mistake. I hope it's not. I mean, the args and the ints are the arguments of vararg. Watch this again. Args and int are the 2 arguments of vararg. Right? While vararg, the whole thing, this vararg and its arguments are the arguments of okay, they are the arguments. They are inside this bracket. They are the argument of our Putchar. Okay, making progress. So that's it. Semicolon, and then of course we want to do h plus plus. By then you know what h plus plus do. It's very important we do this so that we don't still print the percentage d. We skip we skip the character d or I as well after doing this. So let's go and check our code and see whether it works well. All right, I'm gonna save this. I'm gonna go into my main.c file. Hey, be careful with me. So main.c. So in the main.c file, now let's declare integer here. We are using the integer in line 7 to check for return value. And then let me just get another line and say, let's call this one int number. Number, and let's say it's equal to 7. Okay. All right, let's add some lines to our code. Maybe I should have another line here. I hope I'm not confusing anybody right now. It's me updating the value of our value with the new printf statement, so that we'll have this on another line. Printf and the string, let's say up to %d main officials. Okay, let's say code tribe. Code tribe has up to %d main officials. Okay, and the second argument, of course, is the variable holding the number. And of course, we want to have something like this here, right? On this other line. So I will copy this, kill yank, come here, then yank, update this to main arrow 2. Okay, I think it's cool. Yeah, cool. That's it. Now, what I did in line 21, this plus equals means that the arrow value is equal to, it's like saying it's a short form rather than doing arrow value. The new value of arrow value is not equal to whatever arrow value was before. Now plus these new things, this new value you're going to get here. Understand? So if you see something like a arrow plus equals 1, it is the same thing as saying arrow is not equal to arrow plus 1. That way, if arrow was 4, I will now be equal to 5. You know, so if here too, if that's the same thing, exactly the same thing. So if you say r plus equal to 5, so it must not be only 1, and it's something as saying r, the new value of r is equal to r plus 5, and if r was 5 before, the new r becomes 10. So if we don't do that, we will lose the former value of r. If you just go and say r, if I don't do that plus equal that I did in on line 21 and line 14, we will lose the former value of r value. I know r value is saving the return value of our printf for us, so we don't want to lose the one that we've saved before. Let's see now whether this other line will print well. Okay, I want to have a new line here, of course.
Please look at the printf. You said you didn't use my printf for the other one.
Thank you very much. Thank you. My printf, I believe in my printf. Okay, so this is my printf and that is printf. So my printf versus printf, let's go. Okay, so I'm in the test directory and I'm leaving there right now. I will come back later. We need to test some more things. We need to play some more with this Putchar, this standard library Putchar, to discover something about it and see how we can safely implement this %d. Now, these are my files. I can safely compile all the C files here and still have the output as the same main.exe. It compiled without error. I'm going to clear this screen and run it. Alright, code tribe has up to 7 main officials. Yes, the code tribe has up to 7 main officials. And it counted very well. Return value 74. Return value 74. Wow, our printf is working. Our printf is working. Assuming we are talking about 17 here. Embarrassment. I should have changed it to 17. There's no more 7. You see, 7 printed. What happened here was that it did that trick of 7 plus 48, and then 7 plus 48. Look at it. 7 plus 48 will be what? Somebody answer me, please. 7 plus 48 will be what? Let's find it. Hello, fast mathematician here. 55. Good. So it did 7. It did 7 plus 48, and it was 55. So he went and printed the guy that is that is equivalent to that decimal value. That was what happened. Now we now add 17. That will be plus 10. What an embarrassment. But then we now start speaking French and speaking Chinese for us. That's not what we want to do. But let's try and see what will happen. Let's try. Me, I've never tried it before. I'm just talking based on the principles I know. Those are the things I've learned in the past. So I compile again. I like to clear my screen so everything will be up. Let me run it again. What an embarrassment. What an embarrassment. So this one is saying top man okay, sorry, the line you're checking now is Code Tribe has up to 17 main officials. This guy is telling me Code Tribe has up to 8 main officials and it's counting 74. It's counting that he printed 74 characters and of course he printed 74 characters because A is a single character. And then that guy printed, so you don't want this embarrassment. What do we do? How do we handle this? Wow. What's the best way to explain this guy? Okay, let's go and play. Let's play some more. Let's go into that file. Let's play with codes. So this is where I want to use that 5 test.c. So give me 5 test.c. Okay. So if I have a number like this, let's just use 17 and what do I call it now? Let me still call it number, and I say it's equal to, so let's say 1 2 3, and I want to trick Putchar to do this guy because we don't have any guy again to put something to the standard output. We don't have any guy. We designed this Putchar. If you watch the part, was it the part 2? Yeah, it was in part 2 of this series. We derived the Putchar from a standard library function called write, and at least we were not asked not to use write, so we used it and write outputs character. So how do we now? And the only way we can make Putchar to print a number, or yes, the number is to do this trick, and the trick only works from 0 to 9. So how do we now handle numbers that are bigger than 9? Because man, integers are not just what they say is a whole number. Don't forget that integers can be like this. So although there are, okay, let's not go to that place now. Let's not go there now. Just know that you can have integer like this. Yeah, we can have an integer like this. It will save. If you store a variable like this inside an integer, it will save and it will print well. You want to try that? Let's see. If it doesn't print well, you know how to learn new thing now. Print for me. Number equals percentage and give me. Oh, I will get a new line. Don't worry. Don't give me a new line. I'll get. So here we go. Let's go and play. GCC 5 test.c. Name it for me 5 tests to avoid confusion. It compiled. Let's run it. So this will bring me to start expecting something else. So yeah. Let's not go there. I'm not ready for that.
The issue is that you didn't put the arguments that %d.
What?
From your printf, you just said number equals to %d, then you didn't include.
Thank you so much. I was beginning to think, because I avoided numbers that will not enter, that will make it warn me about octa value. I thought it was warning for. I thought I've done, because there's a number I'll put here now. I will expect trouble. Thank you. I didn't even see that. This value. Okay, so you printed the number exactly. So we are expecting that kind of trouble.
Magic. We thought you were doing under magic.
Okay. I understand. But if I have done something like this, I put number 8 here. Let's see what happens now. A little deviation. 1 2 8. I printed well. No trouble. Let me add 9 as well. I like playing with codes. See, it's fun, man. And it printed well, no wahala. Okay, that means our printer has to work like this. Who does not agree with me? If you don't agree with me, go and sleep. Let's leave the car and go and sleep. Our printer must work like this. Okay. So now what do we do to Putchar to make Putchar run through this thing? Let me reduce the number so that I just did that to show you that when some people, I've seen someone who, because he wanted plenty of numbers like this, went and started using array. I mean, there's no point using array if you're not relating with these numbers singly, so individually. If you want them as a whole, there's no point using array. Excuse me. I think I need to power my system before it's too late. That I'm seeing this electricity now. That's me here saying it's wasting. They may just seize it. my system gets slow. Runs slow. Okay. You're making progress. 1, 2, 3. I will get Putchar to do this. You will get Putchar to do this to attend to these guys one after the other. One after the other. We have to use an algorithm that will make it catch them 1-1 and bring them out 1-1. Such that the algorithms will be such that when it has finished catching them, they will be numbers. They will be real numbers so that they can be added. You can do plus, plus will work. You can do minus will work. And now, if I say will a for loop work, this is not an array, so there's no way you can loop into this thing. So the trick that we can use is one that you have used before in one of your tasks. Divide this guy by 10. Get the remainder from the 10. Right? So, of course, I think we need a loop to achieve that. Divide this guy by 10, get the remainder of the 10, and print it. Now, watch this. What I want to do now should reverse this guy like this, if it works well. And that's where recursion becomes important, because it's recursion that will make us achieve this guy to be 1, 2, 3 after we've worked on it. So let me fetch a whiteboard here. Where is my browser? Okay. Okay. Which one goes? Let's take this. Okay, so we have on that place 1, 2, 3, and performing arithmetic on this thing such that we are not concerned with the decimal values. We are concerned with the integer value. This is what I'm going to have. So 1, 2, 3 divided by 12. Sorry, by 10, rather. So do you have a good mathematician? I need one person to just submit and be answering all these things for me. 1, 2, 3 divided by 10 will be what?
That'll be 12 minus 3.
12. With this guy joining. Okay, 12. R3. R3. Right? That's like saying that 1, 2, 3 divided by 3. 10 is 3. But let me keep it side by side like this. So I'll do this. And I'll widen this so that it's still on 2 different sides. So here we go. So 1, 2, 3 over 10 is 12. 1, 2, 3 modulo this is this. Now, when 1, 2, 3 over 10 over 10 has produced 12, we have to do 12 over 10 again. Make sure your answer is correct.
Sorry,
one answering me.
it's not 12 remainder 3.
That's what you're saying. That's what you're saying now. You said it's 12. That 10 is going to have 12 each if they divide this, and it's going to remain 3. So this modulo, when we say modulo, 1, 2, 3 modulo 10, we are saying what will be remaining if 1, 2, 3 is divided by 10. So that's what this is the remainder. But it's important that I use this modulo here because it's part of my algorithm, and I'm not going to be using R in the code. So even if you're still coding, is a valuable thing to do. All right. So 12 divided by 10. Talk to me, sir.
As one remainder, sir.
Great. Let's take it. Let's talk like C programmers. 12 divided by 10, as far as C is concerned, 12 divided by 10 is 1. It does not care what is remaining because it's not working with float. So 12 modulo 10 is now what will give us 1. So that's like asking what will be remaining if 12 is divided by 10.
So,
And now we'll be left with 1 here.
so 12 modulo 10 is 2.
Oh, thank you. I said what you answer. What do you mean I said is 1 or him? Okay, so we are left with 1 here. Okay. 1 divided by 10. What will it be?
0.
Thank you. And then 1 modulo 10. What will it be?
1.
Great.
1.
Thank you. Now, you know that we are interested in these numbers here and not this guy here. Let's say what happened in division, because we want to catch this guy. It's 1, 2, 3. We have separating them. So we want to bring them out to the standard output without Putchar trick and still make them to come out the way they were. Well, let's start now. Let me go back to my code. So, who unmuted want to talk to us?
I just want to speak the name of Jesus.
Please, do I have a co-host there? Thank you. Okay. Now, let's say, okay, so how do I look to these numbers now? How do I look to this number? If I say Putchar, how do I look to this guy? 1, 2, 3. Okay, let's just do this for now. Let's say 4 int n. Don't try this with Betty or those others. For int n equals 0. And n less than, let's say, 3. And plus plus, and each time you plus, what I want you to do, increment, what I want you to do is to put car number over 10, divide number by 10. Let's see, I'm calculating. We need to hold these values somewhere. The new value of number should be no. Don't put anything for us yet. Don't put anything for us yet. So divide the new value of number should be equal to. Okay. I think this my condition does not look right. What if I say if number? What if I use the while loop and say while number is not equal to 0? So long as it's not equal to 0, keep doing this. Number should be equal to, number should be equal to number divided by 10. But if I do this here, it will let me see, let me have value here. Don't worry, I'm thinking my brain is working. Int n n will now be equal to number I'm thinking modulo 10. Yeah, so we want to catch that number modulo 10. So n will be, we'll save it inside n, and we'll say, yeah, I think this here Putchar should work now. Putchar, come and catch what that guy was. So n modulo 10, what was remaining when 10 did the division? Look at our whiteboard again. When we did the division the first time, it was 3 remaining. So it was 3 we want to catch at this point now. It's still want to catch at this point. So number 110 is still, because no number 1, 2, 3 here. So it will catch it. After catching it, give us that tree that you caught. So give us, print that number plus the character 0, of course, which is a trick to make it go and get that number printed for us. And then after doing that, number, the new value of number should be now number over 10. So that it comes to this place now, it checks number over 10, but at this point to be 12. Nice. Yeah. After, it will be 12 at this point. So it goes again, and 12 divided by 10, it will save the remainder here, which is 2, and then put together the remainder, print it out, and come here and make the new value 12 over 10, which is 1, to give us 1. It will now come back here and check it's not equal to 0. It will come here again, n will be equal to, since it's 1 now, it will do 1 modulo 10, which is 1. And it takes that 1 and it puts it to the screen, and then it comes here and number will now be equal to number divided by 10, which will be 0. So at this point, this condition will not evaluate to true again. Then we break out of the loop. Let's see that this will work.
Your line 11, should that not be n? Should not be Putchar n, not number?
Oh, thank you. Should be n, because we're not looking for number now. We're looking for the n. Thank you so much. Okay, I think we are good. If there's no bug in this code, it should work and work well. Okay, so if there's no bug in this code, it will start picking from 3 to 2 to 1, and then we'll start talking about how to make it do 1, 2, 3. Phew, here we go. This is what file is this now? I guess it's 5. Okay, 5 tests is there at the bottom side of my editor. Clear the screen for me. GCC 5. Come on. 5 tests C. Let's have the name or the output into the file. The file 5 test. There was no error. Let's run the 5. We didn't ask for a new line though. Oh. Okay, this is Windows. Windows, do your magic. So it gave us 3, 2, 1. We were able to catch those numbers one after the other. We were able to loop through them and catch them one after the other. So what do we now do to make this thing catch from 1? Catch it already the way they are. 1, 2, 3. The only way we can do that, there might be other ways anyway. I'd like to learn. But one way I know we can get that done is with the use of a recursive function. Yes, it has to be by recursion. So recursion will make 3 wait for 2 to finish, and 2 wait for 1 to finish. And when 1 finish, 1 will not come up first, and then 2 will follow, and 3 will follow. How do I illustrate that in the diagram right now? When we talk about recursion, we're talking about the stack memory. Where so I'll now let me see if I can form a pseudo code. Pick one. Anything pseudo is pseudo. If it does not follow any format, I'll say okay. Now divide the number by. Okay, let's say the division is not even our problem. It's not even our main interest. Our main interest is give, or let's say catch. Let me use the word catch. Catch As catch spelled again this life. Catch the remainder. This is me writing my algorithm. Catch the remainder when the number is divided by 10. Okay, after doing that, last thing is I hope it's not algorithm making sense. Sharp one. I used to wish I have enough time to prepare for these classes. Okay, so you can see I'm just forming everything here, forming the algorithm here, forming my thought pattern, my thought process, everything is happening here live. Okay. Just remember when the number is divided by 10. What else am I going to do after that? Print add 48 to the number and print the ASCII value. After doing that, um, mm, make the new value of the number to equal, what's it called now? Quotient, right? The quotient of number over 10. That means the result of number divided by 10 should not become the value of the number. That's what we actually did there. But what now makes it the question is that if we want to do this, we say why the number, how do I put it? When we write the function, inside the function that will get us this last number 3, that function will now have another command and call itself there to attack, to work on this number 2, right? Such that it will not take a stack form where 3 will now go here and save and be waiting for 2 to be found, for the next number to be gotten. And that next number will be gotten, it will not stay here. And the output will be waiting for the other number to be gotten. And once that number is gotten, it will not stay here. And that one will be waiting for the next one to be gotten. And then the condition says once it's 0, stop. Once it's 0, this side will stop. Nothing will happen here again. So it will not start coming out from here one by one. One will come out first, and then 2 will come out and follow, and then 3 will come out and follow. And we'll now have the 1, 2, 3. If you're able to implement this, our D can do wonders. Right here. Let's see. So let's start to write a recursive function. In this main function, let me write one here. I'll call it what should you return? Doesn't matter what it returns for now. It doesn't matter. No, it should return something. No, it matters. It matters. Okay. Return something. Don't return something. Return something. Don't return something. But I'm not sure again. Well, it doesn't matter. Actually, I think it doesn't matter. I mean, I'm pretty sure it's an output, so we don't know how to return anything. It shouldn't matter. So let me get this, guys. What's the command again? CW. Correct. CY. Emacs. Respect yourself. If you return nothing. Reco. Let me just call it recall. Recalls. take the arguments to be any integer. Let's call it number. Or let me just call it num. Num. What I want you to do is this max. Let us call it this one. Take it down. And the questions again. Okay. I hate to see white lines or white spaces like that. Okay, we are good. Now, how do I make this run recursively? How do I make it run recursively? Y0 is this. Let's see. Let's see. I hope it works. Y0 is this. Of course, yeah, it's num. Y num is not equal to 0. Do this and do this, and then I will now call a function here and say, okay, let me take this out of the while loop. I think I don't need it in while loop. If it works, I will explain how it worked and what happened. Let's take this off. Okay, so now just to explain the recursion, okay. Okay, let me put the code for if the code works. I will break it into pieces and start explaining it. So if this is not 0, do this to it. If it is okay, do this to it and then do what? Let me call the guy now inside self recalls number over 10. Will this work? Will this work? Will this work? Will this work? Let's find out. So I'm saying, as far as this guy is not equal to 0, get all the last digits, print out the last digit, then do it to this guy, do over this. So if this guy is equal to 0, it skips it to. Do I need the while loop? No, I don't need the while loop. I think I don't need a while loop. I think I don't need the while loop. If you think otherwise, please call my attention. I think I don't need the while loop. I think an if loop will do. If this is like this. No, not return. Yeah, so it should be in this kind. Let me see. Let's see what happened. Let's see what happened first. I'm trying to try things.
We are using num, not number again. And your line 17,
Yeah.
n is not declared.
Okay. What?
N is not declared.
Okay, n is not declared. Similar.
Yeah.
Thank you. So n. Okay. I've got some live debuggers here. They debug faster than VS Code. Alright, let's not try. Let's go play. Let's play. So our main file now. Let me now take this off and see how well our function works by just calling the function. So recalls 1, 2, 3. Let's see. It's also what could make it work here and now. Yeah, now. See it's fun. Okay. Recalls 1, 2, 3. Recalls in Oh, I did not declare that here. Implicit declaration. Okay. We know that grammar. Void recalls int num. Any other problem? So
None for me.
compare now.
Top man, I think your network is breaking. I use it for my own
Fingers
end. Please.
crossed. Drum rolls. What will happen? Okay, 31. So is my network? Hello, someone else to confirm. It's not breaking. Hello, can you hear me?
It is actually. Yeah.
Hello.
Yes, I can hear you.
Yes.
Go ahead.
Okay, something is not right here.
I can hear you.
What is wrong with my code? What is wrong with my code? Problem. I got that. And alright, let me do this. If num is equal to 0, return. So if it's not equal to 0, then do this. So now this is because it's okay. Let's see how this works. Why are you taking long? 3 to 1. Ah! No, 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 no. Something is not right. 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 Okay. Maybe I should return something. I think I should return something. So the inner function will return to the outer function. Okay, okay. Let's try that. Just use the power. So I'll do return what now? Return, yeah, return the cause of this. Okay, so let's do it like this. So if this happens, then we should have something. Return with return 0. I think this should work. Because int now, because what's the problem? Conflicting types for recurse. Oh, the prototype did not change. Ooh. See, so much fun, man. Still not working. Why is
Topman,
this guy not working? Yes.
Topman.
Yes, talk to me.
In the code, I mean, in the function recurse, I think
Yes.
isn't there conflict like okay, if num equals to, is that equals to? I can't see very well. I don't know.
Yeah, it's not equal to yeah, equals.
Equals to 0.
Yes.
Return. Okay. But then, don't you think it's because of the variables that are declared like under it?
I don't think so.
The variable num. I'm seeing the variable num like.
I don't think so. That shouldn't have caused it. I think my logic is not fitting what I have on my algorithm. My code is not does not tally with what I have in my mind. So, who wants to help right now? Now we know where we're going. We are in this together. Everybody, all hands on deck. All hands on deck. Let's fix this. Let's fix it. Let's fix it. There's a bug somewhere. There's a bug.
When we also shift like when we're initializing an app like before condition.
Okay, that sounds interesting.
Line 18.
That sounds interesting.
Let's recompile again. We see.
Mm-hmm. I think this guy should follow it up if he's going up. That's fine. I've had that experience. Okay.
Wait,
Yeah, I'm waiting. Go ahead.
I think this Putchar has to be down now. Okay. Has to be see, because now when the compiler runs, it's going to reach Putchar before it reaches like the condition. I don't know if setting another Putchar down.
So you put that should be done. That would mean
Because that Putchar is going to print before the condition is met. There it will print after the condition is met. After
let's run the code. Still didn't work. Still doing the same thing.
But I think, can you hear me? Can I add to
Yes.
something? To
Right,
I think I don't know, but the if statement seems to have an empty condition. So I don't know if the Putchar should be in the recursive also should come down to where the return is your recursive is, because from here, if the number is equal to 0,
I thought that before. Should I use value? Should I use value?
But wait.
Please stop and wait. What is the code supposed to print?
Not 3 to 1. No, that's not what the code is. But I am not. I'm not asking to do what I want you to do. Actually.
So maybe see what you have put in the code. Okay, if num equals to 0, if num equals to 0, then we assigned some. We have initialized n with num. Okay, product of num. So I don't know if I think let's just declare num. Topman, let's just declare num. In num, then we can do this assignment of
num is the argument already now. I don't want to declare it. Do you? Huh?
Topman.
Yes.
This code, that n, our n is non-modulo 10. Then the Putchar is asking the compiler to print n for us.
Okay.
But we are supposed to print the 1 first. But in this case, the compiler will be printing the last number first because it's non-modulo 10.
That is what I was trying to say. But then, Topman, anyway, that num is a variable. That num is a variable, also.
Yes, it's a variable.
And we are using it before declaring it.
No, num is the argument itself now, not just a variable. Look at it, num is the argument.
Okay.
Okay, let me try with the while loop and see what happens. Fingers crossed. You're playing with codes. Okay, why this is not this?
I think we should not use Putchar first.
What should we use first?
Like, we shouldn't print until the all the recurse function has finished the iteration.
But then they're supposed to have the same instruction. You understand? And we also need to have a way that the print I just lost something. My clipboard just lost something. Okay, so we need to have it in such a way that it has the instruction but waits for the other guy to execute. You get that?
Yes, I got it.
So let's see. So that's what. If you're thinking that light now, then you're for me. All right. Let's try this again. Let's see how we can run it once. Okay, let's try this. So I haven't
Thomas, don't you think
understand
the
here.
return is supposed to
I
be
have
out?
not equal to 0 here. I thought so before. I don't know why it didn't work. Let's try. Trial errors that we learn. 31, it's not working. If I take it out, does it make any difference? Does it make any difference? Okay, I think I need to consult Google at this point. Something I'm not doing right here. There's obviously something I'm not doing right here.
Let's first try with the return outside.
Topman, can we store the recurse in a variable?
The what?
The recurse.
The recurse in a
norm.
variable.
Yes, recurse norm divided by 10.
If we store, okay. If we store it in a variable, what will it give us? The variable, the content of the variable will change each time the code runs. Right? If we store it in a variable, the content will change. It will just save to be 3 first. It will not save 2 and discard the 2. Override the 3 that was saved. And then if you save 1 at last, so it will have single value, and we can't concatenate it. So. What did I do that is making me run to why name is this? Let me go to this. Okay. Now let's come back to our whiteboard. I think we should fix it here from whiteboard first. Let me be particular. So let's start from the step-by-step way to solve it. First of all,
Topman, can you hear me?
I can hear you, Naima. I know that voice.
Okay, you're trying to make the recurse function print backward, right? You passed in 1 to 3. You want to print 3 to 1.
Yeah. No. I want to print the 1 to 3. 3 to 1 is not nothing I will get. I want to print 1 to 3. Yes.
Okay. How about you put the return? The if you tried before. How about you put the return before putting before calling the putchar function?
Okay, return before calling the putchar function. The putchar function will only attend to the last guy. Let me make sure I got you. You're saying putting return before calling this guy. Is that it?
Yeah, with the if this thing you were trying before, if num equals 0.
Wait, let me see. Okay, if num equals 0.
Yeah.
I didn't get that. Type your pseudocode and send it to me. Type your pseudocode and send it to me.
Let's whiteboard it together. Yeah.
Okay.
Let's whiteboard it before write the code.
Let's roll.
So let's use the here. I don't think we need the while loop. Okay. Let's say if number is equals 0, it should return 0.
So if number
is equals 0, it should return 0. Else, it should get
return 0.
yeah.
Okay.
Else it should the norm that is coming should be divided by 10 and stored.
Okay.
Maybe we'll be able to hold that.
Norm should be divided by 10.
Yeah. Let's give another variable that to hold. Let's call it maybe n to hold whatever is coming from the division. You get?
Okay.
Yeah. So you can say n equals to the norm divided by 10.
So n equals to
Yes. Then we can now call the recurse.
is this all?
No, we will now call the recurse function again. Recurse, we'll pass in n.
Okay. Are you sure?
Yeah, let's try. If it's
recurse.
Yeah, recurse. You pass in the n that is coming.
Recurse n. So what happened to the modulo? What happened to the print modulo we want?
Yeah, we'll definitely put it.
You know, it's the element that we are targeting.
Yeah,
Okay,
after
so
the recurse,
where is the best place to put it?
We'll now put, after the recurse function, we'll now put the norm with 10.
This doesn't sound like it will work.
Let's do this now.
It may work.
Remainder.
Norm modulo 10.
Oh.
10 plus the ASCII, that's 0 input. It will now return 0.
Are you sure? Okay.
I don't know. Is your screen frozen from my side? Can't see it clearly.
That's right.
The last thing I'm saying is the norm modulo.
My screen is moving on. Where else? My screen is frozen. No, someone else to confirm. Is my screen frozen?
Okay, it's back. It's back.
Is my screen frozen?
It's back now.
Okay. What can you see?
You can see. No.
Okay.
Brother,
I can see your Emacs now.
All right. Okay, so I want to implement your code and see. Now we will have to debug it here today. We'll debug it. It has to work, even if it means yeah, so I have variable int n. Yes, and so you say if this guy is equal to 0, we should return 0. And then else, what is up with my editor now? Okay, else num n equals this over this. Okay, and oh, just like that. Oh. Then he said we should call for the function again, recurse n, and then inside recurse n, we'll now put gadgets, man. Okay. Is this it? Is this what you mean?
We are put carrying the norm modulo 10.
Okay. No modulo 10 plus this. Okay.
Then return, do you want to return 0 there or something?
Topman, you have left the semicolon on the recurse and you called.
Okay. Return 0. Huh? Fine. I'm not concerned about the number now. I'm concerned with the code. Okay. All right. Let's go check. Clear the screen for me. Compile that file again. Wait. 1, 2, 3. All right. Let's explain the brain behind your code. I'm wondering why this works like this.
So the function is taking norm as an argument, right?
Okay.
So we're saying if norm is 0, it means that it will mean that all the digits passed has been printed, right? And the function returns 0. Yeah. Then the function initializes that integer n. It will now assign the value of norm divided by 10 to it. The function will now call itself. It will now pass in that n as an argument to print the remaining digits that is coming. I don't know if it makes sense.
Okay. So let me take you bit by bit. At this point, there was a at line 12 there was a variable not initialized. Line 14 a condition checking to make the function not run um, if norm is equal to 0, and then if norm is not equal to 0, it will not save. And at this point, when n was 1, 2, 3, what did you save inside n? It's not.
Sorry, Topman.
It's
Do you
not
still
12.
have
Yes.
do you still have the previous code? That was when I left though. The previous code that you wrote before that was giving you 321. There was something you should have done in that aspect.
In that particular code,
in order for you to pick from the top instead of from the bottom. In order for you to from the bottom rather, just call the recurse before you call the Putchar, so that the recurse will run. So when you start printing from the last value of n, which is 1.
Okay.
Do you understand? I think.
Okay. The code is gone.
You understand now?
I understand. So I should the recurse comes before the Putchar.
Yeah, the way you explain you using that stack.
Thank you very much.
You want it to pick from the bottom instead of from the top. So the recurse should come before the Putchar. So the Putchar will pick the last value, which is 1, then to the next one, then to the next one. You understand now?
Okay.
Yeah.
Okay. So at this point, n was equal to 12, right? And we now so what we actually had here was recurse okay. By this now we've interrupted the printing of 3. Okay, guys, do you follow? Whoa, interesting. So at this point, I remember using recursion to implement pyramid, and I made a similar mistake. This kind of mistake, and it didn't work as a recursion. When I moved one line to the other, and then it worked. I think it was the thing I did. Okay, so at this point, I think there's no confusion. Norm as for if norm is 0, it will not. At this point, norm was equal to 1, 2, 3. So at this point, n now became equal to 12. So we separated. Norm is saved. Okay, fine. N is equal to 12. So at this point, let's say recurse 12. Now, rather than put carrying this guy first, we now made this to first run this guy before put carrying the code. the result. What that did was that it went to this guy, and inside this guy as well is all of these instructions again. That was my mistake. Nice one. Inside this guy is all of these instructions again. So this guy will run all of these instructions again. What I mean by that is when you let me take it to my whiteboard. Will you copy this in or not? What's the W? Okay. Emma, thank you so much for coming to my aid. Mr. Godo. Now you agree with me that C is fun. Okay. So here it is. Now, when you, at this point, like I said, at this point, num was equal to 1, 2, 3. So so it was not 0. So it didn't run this particular part. It skipped this part and then ran this part where n was not equal to num over 2 over 10, and num over 10 at this point was 12. So at this point we will call the recurse again. Instead of this guy printing, if this guy had come like the mistake I made before and brought it up first, it then printed 3 first. Because this guy is here, he cannot go and print 3, he has to run this guy first. And this guy, recurse 12, is another whole. Now watch this. What is? Let's just assume that we did the recurse 1, 2, 3 here. Recurse 1, 2, 3 here. Yeah, which was actually what we did on main file. So recurse 1, 2, 3 ran here and did not print the 3. Before printing the 3, went and did recurse 12. And recurse 12 now did this thing again, this whole thing again. Let me duplicate it. Very interesting. Here's our pseudocode. Here is the first stage, what happened first. And here's the thing that happened next. So at this point now, it was recurse 12 running. Recurse 12 was running. And at this point, num was equal to 12, you know. And then num was not 0, and then it did num over 10. Num over 10 was equal to 1 at this point, and it did not also print its value. It went and did recurse 1 as well. And then let's take it. Hey, stop that.
I still really don't understand.
You don't understand?
Yeah. I really don't understand how it works.
I think I understand what's happening now.
It's 11. Don't worry, just when you finish explaining this, can you explain from the first pseudocode that you wrote? Use that one to explain again, that stack that you were doing before. What went wrong with that particular code, so that they might actually understand from that one better.
Okay. Let me finish. Okay. I will turn everything together to see how I can communicate it. Let me call this step 1. I will call this step 1. Step 1. I will call this step 2. And I will call this step 3. Step 3. Don't worry, making progress. Okay. So when we called, now let's go back to the first one. The first one I wrote that I intentionally printed 3, 2, 1. Okay. So first we cut the remainder when 10 is divided by 10. Sorry, when the number is divided by 10, and then we printed. This is what we did. This was what we did differently in the recursion. We didn't print. We inhibited the printing, and the printing depended on the right guy. on the other guy is getting printed first. The last one getting printed first. But yeah, we printed, and after printing, we then made a new value to be number over 10. But in the other guy, we didn't only catch the number. We caught the number and we went and make sure we had this value. Worked on it first, and this guy became the last thing that was executed. Now, watch this again. Watch the code again. At this point, this code is executing. It will come back. Watch. It will come back from step 3 back to step 1 because step 1 has executed, and step 1 stopped here. Step 1 will not go beyond here. And here became step 2. So this is me magnifying step 2. This is me expanding step 2. Step 2 started running 2, and step 2 got here and stopped and did not complete. And this was the running part of it. Now into step 3, and step 3 now got here. Oh, that was a step 4. It got here and stopped and did not complete. Yes, that was a step 4. Step 4 was the point where it met the value to be 0. Just don't worry, I will take it again. I will take it again. Don't worry. Let me make my screen accommodate that. Or how do I do that now? Let me make this one smaller. This is the pseudocode. Let me call it pseudocode. I'm coming, don't worry. It has to enter, that's why we're here. We came to learn, right? Pseudocode. Okay, this is the pseudocode. This is step 1. This is step 2. This is step. So I wish I can put them. I think I should put them into boxes so that. So at step 4 now, what happened at step 4 was that recurse now has the argument of 0, it had the value of 0. The n now had the value of 0. 0. And here n was equal to 0. Don't worry, I'm coming. And then here, it didn't even get to this place again. It didn't even get to this point again. And here, it did not cost anything. And it didn't even run this path. Now, let's take it.
Recurse 1, not 12.
What?
Your step 3.
Okay, step 3.
Yeah, recurse 1. Yeah.
That's correct. So recurse 1 here. Recurse 1 here. M divided by. No, yeah, 0. Num will now be equal to. No, num was 1 here. Then num divided by n will be 0 here. And you have to do recurse 0. I'm coming. Maybe I should take the comment off and do recode. Let me take the comment off. At this point, I will take it bit by bit. Let me take off this comment and really replace the code with what is really happening inside there. That's it. No. Okay, so I'm taking it from the beginning now. So when we called recurse 1, 2, 3, it came to the first line and said that okay, there's a variable here called n. It came here. If num equals this, let me take this comment off. Like I said, I don't want any comments in this code now. Let's work with recode. Let's behave like we are the compiler running the thing. We are putting the compiler in slow motion. Here is replace num with the value 1, 2, 3. 1, 2, 3. And it check, is 1, 2, 3 equal to 0? No. So it didn't run this place. It didn't run. It skipped that if and went to the S. And here S became 1, 2, 3 divided by 10. Who has the mic? Who has the mic disturbing? Please mute the mic. Thank you. So 1, 2, 3 divided by 1. And this, that means n became equal to 1, 2, 3 divided by 10 will give us 12. N became 12 here. Right? And then when n became 12, n got to this line. This line did not allow it to pass to the next line to put it. The line did not allow it. The line had to stop it here. for it to go and find recurse 12. Because that is recurse n. N is 12 now. So it has to go in for recurse 12. And what is recurse 12? Recurse 12 will do everything that this guy did here again. Because recurse it's calling itself. So recurse 12 now run into this step 2. This is my step 2 now. And then it checks for an n here. Sorry, num here now. Num. Excuse me. What is the argument? Num or 12? I refuse to be confused. Recurse num. Num is argument. Something is missing. I've missed something. Back to the code. Num equal to this, n equal to num over 2. So yeah, I think I'm correct. N equal to num over 2. Recurse n, I think I'm correct. So num and n is almost working at the same thing. Okay, so it comes here and does recurse 12. So it goes for recurse 12. As recurse 12, num is equal to 12. So it replaces this variable num here with 12 and checks, is 12 equal to 0? No, 12 is not equal to 0. So that block of code that returns 0 does not execute. It goes to the else and say else is n now is now this 12, which is the argument num, over 10, and 12 over 10 is equal to 1. So at this point n now became equal to 1. I think let me not hide too much details. Here was 1, 2, 3. Let me not hide too much details. Here was 1, 2, 3 over 10. Over 10. And n became 12 here. Okay, stop that. N became 12 here. Okay, so I don't have too much details. That comment might be needed. And it's a comment actually. So n became, so at this point now, it has divided 12 by 10 and n is equal to 1, and we say the recurse n. That means it will do recurse 1 now. It will not run to this part. It has not gotten to this Putchar. This part of the code is waiting for this side to finish before it will run. It is waiting. So after this recurse n, this particular recurse n, it will go. This recurse n will be recurse 1. It will enter into step 3. It's still building the stack. Let me draw something here to be representing the stack as I'm talking. So at the first point, it has gotten that it doesn't know what non-model is yet. Sorry, it knows it, but it cannot put it yet. It's just holding it. It knows that non-model 10 is 3, but it cannot put it yet. At the second step, it knows this guy, but it cannot put it yet. Right? So it gets to this line, and it cannot go and put car. He has to do recurse n. Recurse n here will become recurse 0. And for recurse 0 will not even meet all this condition. Because recurse 0 will hit this if condition here and return 0. So when it hits this what is it called? This if condition, num is not equal to 0, it will go back to step 3. That is the question for you. At this point, before that point, it already had 1. It already has 1. So when it goes back to step 3, it will not execute the remaining line. And there's only one line remaining. That line says Putchar num modulo 10 plus this character. You already know what the character is doing, right? You already know what num modulo 10 is. I mean, num at this point was 1, and 1 modulo 10 is 1. That is 1 divided by 10. 1 divided by 10 will give us 0, remainder 1. So it will not print that 1 here. And now run back to step 2. Step 2 will now execute the remaining line that is left, which is to print this 2. It will run back to step 1. Step 1 will now execute the remaining line that is left, which is to print this 3. Okay, let's see how many more people don't understand at this point first. Who does not understand? Who does not understand? Is there any person here who does not understand what is happening? You have some knowledge of even if you didn't have knowledge of recursion, with what you have done now, this is more like teaching you recursion. So everyone understands. Okay, who understands? Raise your hand. Who understands? No one understands. Okay, I'm seeing hands raised.
I understand, man. I understand.
Okay. So only Stephanie understands. Who else understands? So if I call any matter, you should explain now what happened. You can explain, right?
Yes, I can.
Okay, no, I'm not even talking to you actually. I'm talking to others now. Other systems are not real. I don't understand. I don't understand whether you understand or don't understand. It's okay. It's recorded. I think, Mr. Pedro, do you want to add something to this?
No. There's nothing to be added. You've explained it all.
All right.
Don't worry. Just so they know that this their printed project requires a lot. All the previous projects you've done, memory allocation, recursion, variety function, and the likes of them, they are all applicable under this project. If you are not familiar with any of those topics, you might be finding it difficult to even start the printed project or even go further along the line. So you can see from printed we are discussing recursion. So people will be like, is it recursion we are discussing or printed project? So that's just the thing.
So it's doable, it's doable, it's doable, it's doable. We can do it. We can do it. It can be done. So if you want to take a look at this video again and put that part on repeat until you grab it, I think I've explained everything I can explain for now. I can explain. Thank you once more, Neymar, for coming to my rescue and Abiodun. So I was the one looking for this trouble by bringing this Putchar out first. So when I bought the Putchar out, it then Putchar the character and then continued. So at the end of the day, I was not achieving what I should achieve with the recursion. I was not able to build a stack. You know.
Yeah,
So
that's your code work.
Yeah.
All you just have to do was just to put the Putchar up and then put the records down. You don't even need to return there. Yeah, the very first one you wrote was working.
All right. Thank you very much.
That,
All right, let's go and make our printf handle percentage D. Aren't you excited? Okay. So I'll go back to the file. Come on. Come back here. I'll go back to the file. My printf. No, I want to have a new file right now. At this point, I think I want to have a new file because I want to define the guy that will perform this recursion. I want to find the guy. So let's call it. Let's go back. I think we'll finish playing. What's this? I have file that's not saved. That's not the file that we run now. Let me be sure that it's working well. If I leave here. Alright, 1, 2, 3. Good. I wish I would have time to comment on this code very well. If you want to volunteer, let me add you as a collaborator to this repository and then you comment the codes very well. You know, put nice comment that will make someone understand while looking at it. Just give me a message on WhatsApp and I'll add you as a collaborator to this repository. This is actually a repository, right? I'll store the codes here so you can play with them. You can get with them. So let's now create. Let me leave that directory. No, come back. And create a new file. I'll call this one getInt. So create a file getInt. .c, and of course we also want to return yes, there has to be a way for us to return integer, return the number of things characters printed. Yes, because printf does that. That's the number of characters printed. Okay, so getInt.c, I have it there. I don't want to write too much, so let me copy something from anywhere. Copy something from what one? Let's say my boot. Okay, let me copy something for this file that we wrote. Copy portion that we wrote. That was 5. What am I doing? Test 5. Let's see. Copy it into getInt. Alright, so let's look for the file. getInt. So where is this? getInt.c. Alright, so want to turn this file into our function file, so I'll just take this off, take this line off. So int recurse, I'll call it getInt now. So getInt takes an integer as an argument, We don't want this guy here. We don't want him in our kingdom, in my printf kingdom. So rather, I think I should get this guy back and take this one off. Rather, get our guy header.h. This is our own header file. We are independent from standard library as far as our printf is concerned. Okay, so I think we are cool. Yeah, we are cool, but we need to add another variable that gets the value. Let me still call it rval. I guess return value, which of course is what we should return here. R value. Okay. So what will be our R value? It has to have an initial value of 0 here. So we increment it each time this code run. So we'll say I think at this point when you print, at what point should you run? I think it should run here. If it gets to this point, then it should run. So say rval plus plus. Okay. Yeah, it's not bad. Yeah, it's not bad. It runs here. No. That's equal to 1. This should work better. It's not the same thing. Well, this one will save it. Yeah, this one will save it. I think they're not necessarily the same thing. Okay. Yeah, so what's happening in my thought process? Here we go. Call this. Go and add this to the header file. No, header file should be here already. So header file. Header that's H. Okay, and then you've got a new prototype. And as you're doing, come on, what are you doing? As you're doing it, your oh, what is this? What did I copy? As you're doing this, your header file keeps getting longer, lengthy, more lengthy and more lengthy. I paste this here. So let's now go back to the. You're seeing what is happening. I've not done any magic. I just picked the file, which the file which we ran now that is working for us. I just got it now, and I want to use it to be able to print numbers. Any amount of number. Before, see what happened before, where we are able to print from 0 to 9. Our printf was able to print 0 to 9, but not able to print when it's more than 1 digit. It was more than 1 digit. So that's what we're trying to achieve right here now. And we also want to have the return value. That will return how many characters was printed. So that our printf will be returning how many characters was the number of characters that was printed, like the standard library printf. So that's what I've done here. I just added the prototype to the header file. I've not done any magic. And now I'm going to my printf to implement it there. Okay, to change what I did before. So my printf, let's see inside here, see what we did before. We use the function Putchar, but right now we use this new function getInt. So getInt will attend to it if it's 1. GetInt will even attend to it if it's 0. It will handle it and not print anything. So sorry. No, it will print something. We get it attend to it if it's 0. Let's find out. If it's 0. Yes, our recursive function returns 0 when it's 0. But let's find out. We'll find out. So let's go back to our test file now and see how well this guy is working. Okay, so we still have 17. Yeah, let's see whether it's able to print 17 now. I think this is cool. Let's say it's able to print 17 now. So GCC all of the C file here and give me an output with the name of men. Okay, what are those sellers for? Print n, alpha equals 0. What's the problem? Alpha is initialized in function getInt. Alpha is initialized What's that? Expected declaration specifiers. If I didn't put semicolon. If what? Expected declaration specifier before else. Something is wrong somewhere. So let's go to that file. Get int. Buggers. Okay. Um, I've not seen the problem. Who has seen it? Who has seen the bug? Int and arval equals 0 int this. Error says spread declaration specifier before r value. What do you mean? What is the matter with this guy?
Okay. After the function, there is no open brace before the int end.
Thank you. I was even thinking it's my error, so that's why they are called bugs. Buggers. What is it again? Putchar. No. I'm not even interested in this Putchar. Why did I use Putchar? Give me my Putchar, Joe. Oh, well, I have a guy that can do the Putchar. And then go send again. Recurse and doing what? Implicit declaration of function recurse and okay. It's not recurse again, it's get int now. What else? These are the both two errors remaining. Okay. So I hope you know that these errors are part of the learning. Leading errors and knowing what the error is part of the learning. So yeah, I just fixed it says implicit function. That means I'm declaring a function illegally that it does not know, and it was correct. I didn't change that to get int, and it says Putchar was declared here. We're not using the there's nothing like include ASCII in our header file, so it does not know what Putchar is right now. I think that's fixed now. So let's go.
Man, do you know why I love JCC?
Talk to me.
I love it because it will even suggest for you if you're only keen to read what is throwing you the error, then you would have solved the problem even by almost 60% plus.
Wow.
But the problem is majority of us, when you see an error, you're scared now. You don't read the error message and just start figuring the way out. Sometimes the error messages even have the solution already in them.
Okay, so I made a mistake here. I was adding this character whereas our function has it. I didn't. Our function has the ability to add the character 0 to it, so I didn't need to add it. Okay, so our guy is working well now, but he's not counting. He's not counting 75. It's counting 74. What is not counting? That's something that our function is not counting. Why? Why is it not counting? Let's go back. Our function has to work. In fact, let me use some more stubborn case. Int one run. Let's say okay. Let me use. I want to use one wicked number. One wicked number. So I'll say percentage. No work. Percentage D percent is possible. Okay, average is possible in area X, CX, spacebar, take the left, W, then come here, take all of this off, CY, making progress. Let's see what it prints first before we start making sure our return value counts well. Clear this and run the file. 150% average is possible in alias, 150% average is possible. It counts 69, this one counts 67. That means this guy is counting only once, and that's not what we want. That's not what we want. So let's go and make sure that doesn't happen that way. So get int.c. All right. So at what point should this guy increment? I think it should increment inside the loop. This is this even needed? This statement doesn't look needed. It doesn't look needed. This our code will work with other else. So let me put this guy here. Hopefully it should work well there. Print this, print this, print this, print this, and then okay. Okay, fine. Let's take out this S and see. Look, I'm not about to spoil this code. Bam bam. Okay. So if this happens, return. It does not happen, continue do it like this. Let's see what happens. Compile my code again. Any error? No error. Run the code again. It's still not counting well. Why? Okay, so I want to talk. How do we make sure our value counts very well? It's counting the whole thing as one number. And that's not what we want. That's not what we want. Should we ask it to return this plus 1? R file.
Sorry, I just came back. What do you want to do?
I want to have create return value. No, this will not work. So I'm looking for a way to have step 4 will return 0 to step 1, and step 1 return 1 to this, and that return value will increment again by 1 here, and increment by 1 and return to the main to the function. So why is it not okay? I did not see the return value anywhere in this function. So let's say our value plus equal to, okay, let's see how this will work. So it didn't work as I expect. It's only 68. Why this guy is cutting 69? Why? Why are you returning 68? Okay, I think I've gone for it. I think this is a small block to debug. You can get it. I get it right. I mean, if we spend some more time here, we're going to get it. But this is getting much longer. Um, fix down, let me down for you. Fix it by yourself, and then see how well you can dive into the advanced tasks, make some good attempts, uh, fight as much as you can fight, get solve as much as you can solve, as much as you can solve. By the way, if you know exactly what I should do right now to make sure that return value is accurate, you can let me know too. I really appreciate. Mm, it's just accurate. Okay. Dun, 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 dun. Let me do something more in our test file. Just to be sure what is happening here. I think at this point, I should. No. Any questions, please? At this point, I can use my printf here. Yeah, I can use my printf here. Now it recognizes the D. So everything down from 17 down is our own code. Everything up is standard library function. Any question? No questions. So we are good to go. What is making this in my print? What will happen if I uh, mm, let me make this number bigger. Let me just see. Uh-oh. 4 more info. I hope it's not somebody's really contact I used there. Call versus the D. I hope it's not somebody's really contact I used. Let me get this as well. CX space. Meta what? W. I just want to check how well this guy is able to count return value. For more info, call this. Alright. What's up? Invalidity is 9, I know. Octa value. So why did it work out first time? Okay, you see 0 first. Okay. Because you saw 0 first, you now call it an octa value. Something overflow, replacing constant, what. Okay, let's see whether I will work. No, I will change the number. Sorry, 70 this. Time to do this magic. What is the problem? Overflow implicit constant conversion. Where? Okay. All right, ladies and gentlemen, the only bug here now is that our get in function is not returning, we're not having the values returned, and there has to be a way to implement the proper return value so that does not affect. I think that's the only thing. I think is from it. So let's get in so that it returns the number of times it runs this function. So um, mm, 61. This guy has um, how many digits? 1, 2, 3, 4, 5, 6, 7, 8 digits. And this guy is 6 higher than this. So how did it take a few digits? What is happening? Find out, and maybe it's in our return value, maybe it's in the way we're implementing this, maybe we need to use some loop, maybe we need to do what. Whatever it is, um, at this point I want to join the curtain, fix the bug. I may fix it and push it to Git for you. I'll be push the right code. The code with the bug fixed. Yeah. I'll do that. I'll do that. But tell you, I want to find out what could have caused it. So I want to thank each and every one of you for joining this section. Wow, it was not easy, man. Man, for me it was fun. Going back to what I studied a while ago. I mean, for me it's like testing to see how many of it was retained in me. It's fun. It's fun. It's fun. If I had enough time to prepare for this class, I probably wouldn't have been going through what I went through. I'd have been. I'll just know. But for me, it's an opportunity for me to learn like this. It's an opportunity for me to test whether what I've learned is really inside me, was really retained in me. I mean, how much I can remember about what I've learned. So I want to thank each and every one of you for being part of this session. God bless you all. Keep learning every day. We have. I invite you for our event tonight at Twitter Space, Code Tribe Community Hangout. We'll be having Jesse from Just Inspired with us. And he's going to be inspiring us. That guy is going to be graduating in a few weeks from the time of this recording. Yeah, we should even be cutting in days, and it's coming to drop some things into us. It's coming to fire us up, and yeah, you don't want to miss it. If you're in cohort 9 and you're here, there is a section on load balancing that will be handled by Dr. Obed Ohonia from Ghana. Yeah. Extraordinary human. He'll be superhuman. Yeah, he'll be with us tonight at 7 p.m. GMT. You don't want to miss it if you're a cohort 9 member. Alright, so for now, I want to say thank you and have enjoyed the rest of your day. Okay.